Hey guys, welcome back to Science Free. Today's lecture is about ratio and proportion. Before we start, let's talk about measurements and unlike measurements. So like measurements are measurements that have the same unit. For example, 5 yards and 12 yards would be like measurements, while 9 gallons and $106 are unlike measurement. Whenever writing a ratio, always check to see if the units could be converted to have the same unit. The ratio is used to indicate how many times one number could be divided into each other. We could change the 5 feet from feet to inches to make the units the same for both numerator and denominator. Because 12 inches equals 1 foot. We times the 2 feet by 12 to check how many inches are in 1 foot. We get 24 inches. So we have 5 inches over 24 inches. And now we can cancel the units, because they are the same. So here we have 15 divided into 3. When referring to this as a ratio, we state it as 15 to 3. So here we have a ratio with the same units. What do you think we need to do? We cancel the units when they are the same. Let's write 36 yards to 27 yards as a ratio. Notice we place 36 in the numerator and 27 in the denominator. This is because 36 is stated first. We again cancel the units, and we left with 36 over 27. Since ratios are fraction, they can be reduced. Let's reduce this ratio. What is the largest number that can go into both 24 and 15? That largest number would be 3. 24 divides into 3 equals 8. 15 divides into 3, that equals 5. Here's one for you to try. Write the ratio of 9 books to 5 books. Again, because the 9 books were stated first, we write it first in the numerator, and 5 books in the denominator. We cancel the units, because they are the same. Let's write the ratio of 38 chairs to 19 students. Remember that ratios are fractions, so they can be reduced. What's the largest number that could go into both 38 and 19? That number is 19. 38 divides into 19 gives 2. 19 into itself gives 1. So we have 2 chairs for every 1 student. So let's talk about rate now. Rate is a ratio, where in this type of ratio the 2 terms are in different units. Okay, here we have a car traveling 350 miles on 20 gallons of gas. This is an example of rate and ratio. So let's solve this question. Let's reduce the fraction. What is the largest number that could go into 350 and 20 without leaving any remainder? That number is 10. 350 divides into 10 equals 35. 20 divides into 10 equals 2. So this car takes 2 gallons for every 35 miles it travels. I want you to now write the ratio of 279 to 42 in its lowest term. So what's the largest number that could go into 279 and 42 without leaving a remainder? That number is 3. 279 divides into 3 equals 93. 42 divides into 3 equals 14. We get a ratio of 93 over 14. What about this one? Let's write 20 to 10 in its lowest term. What is the largest number that can go into both 20 and 10 without leaving a remainder? That number is 10. 20 divides into 10 gives 2. 10 divides into itself gives 1. Let's solve this one. From reading, there is a rod of length 58 inches, and that of another is 18 inches. And we want to write a ratio to compare their length. 58 is stated first, so we place 58 in the numerator and 18 in the denominator as it is stated lastly. Let's reduce the ratio. What is the largest number that could go into the numerator and denominator without leaving a remainder? That number is 2. 58 divides into 2 equals 29. 18 divides into 2 equals 9. It is reduced to 29 over 9, and this is the same as 29 to 9. In this next question, there is a school library that contains 2,200 books, of which 1,300 of those books are science books. Well, the rest are just history books. And we were asked to find the ratio of science books to history books. The total number of history books was not given. But it is quite easy to find, since we have the total amount of books in the library, and also the total number of science books. So we just minus 2,200 from 1,300 to get the number for the rest of the books, which are just history books. So subtracting 2,200 from 1,300, we get 900, and that is the number of history books that the library contains. We can now write the ratio of science books to history books. Science books were stated first, so we write it in the numerator, and the total number of history books in the denominator. That's 1,300 over 900. Now, what is the largest number that could go into the numerator and the denominator? That number is 20. 1,300 divides into 20 gives 65. 900 divides into 20 equals 45. So our ratio is reduced to 65 over 45. In a biology class, there are 38 students, of which 20 are girls, and the rest are boys. Write the ratio of boys to girls. We don't have the total number of boys, but we have the total number of students, and also the number of students that are girls. We minus the total number of students from the total number of girls, and that should give us the total number of boys. 38 from 20 gives 18. So 18 is the number of boys that class contains. We can now write the ratio of 18 to 20. Reducing this fraction, we think of the largest number that can go into 18 and 20 without leaving a remainder. That number is 2. 18 divides into 2 gives 9. 20 divides into 2 gives 10. This ratio is reduced to 9 over 10. What if we have a ratio question that requires us to find the largest and smallest share when some amount of money is being shared in a ratio? Well, here $310 is being shared in the ratio of 3 to 1, and we are required to find the smallest share. The 3 is used to calculate the largest share, because it is the largest of the ratio. And the 1 would use to calculate the smallest share, because it is the smallest of the ratio. So we now need to calculate the sum of the ratio. That's 3 plus 1, we get 4 from adding. Now to find the smallest share, remember that 1 is the smallest number of the ratio. So we divide 1 into 4. And times the fraction by 310, we get 77.5 for the smallest share. What if we want to calculate the largest share? We would still add the ratio, and divide the largest number of the ratio and the ratio total, and multiply it by the total amount of money. For the largest, we get 232.5. Moving on, let's now check and solve proportions. So we have 7 over 29 and 6 over 20, and we want to know if when we cross multiply both sides are equal. Multiplying 7 by 20 we get 140. Multiplying 6 by 29 we get 174. So they are not equal. Now we have 12 over 21 and 24 over 42. Let's check if this one is equal. Multiplying 12 by 42, we get 504. Multiplying 21 by 24, we get 504. So this equation is proportional. What if a tall building which is 39 feet casts a 12 feet shadow, and the shadow is 4 feet long? What is the height of the building? Okay, so we can use an equal sign to state that the building is 39 feet, and it casts a 12 feet shadow. The shadow is 4 feet long. Note carefully that we have two same units working with, which are 12 feet shadow and 4 feet shadow. So we place 4 for the denominator. We only have one term for working out the height of the building. We don't know the height, so we use x to represent the height. Cross multiplying, we multiply 12 by x, we get 12x. Multiplying 39 by 4, we get 156. So we get an equation 12x equals 156. We now are supposed to find what is x. So we got an answer of 12 feet for the building. Let's do another example. Say we have a car that is traveling at a constant speed of 75 miles in 1.5 hours. And we want to know how many miles will it travel in 1.6 hours. The car travels 75 miles in 1.5 hours, so we use an equal sign to show that. Next, we find like quantities. 1.5 hours and 1.6 hours are like quantities. So we divide 1.5 into 2.6. If you notice, 75 has a unit of a mile, and the rest have a unit of the hour, which means they are unlike terms. And the question asks us to find a mile, so we place the mile in the denominator below the 75, because they are like terms, and use x to represent it because it is unknown. When we cross-multiply, we get 1.5 times x equals 2.6 times 75. 2.6 times 75 equals 195. We now are supposed to find x. X is a number, but we don't know what it is. Because the opposite of multiplying is dividing, we move the number that is being multiplied by the letter on the left-hand side, and divide it by the number the equation is equal to. 195 divides into 1.5 equal 130. So, that means the car can travel 130 miles in 2.6 hours. Thank you for watching, guys, and if you haven't, please like and subscribe, so you won't miss out on any of our maths and science tutorials weekly, as we will break them down to you in an easy way for you to understand and follow. Also, don't forget to leave a comment, or you could email us through our email in the description.